Hello, Science 20s. This is a quick lesson on moles and molar mass. Both of these two things have already been covered in Science 10, so this is just a quick review. Okay, if we take a look at what is a mole is merely just a number in chemistry. So, kind of like you think of, hey, a twin is 2, a flat of soda pop would be 24, a dozen eggs is 12. A mole is a very, very big number, 6.022 times 10 to the 23rd particles. Or this big long thing, if I take it out of scientific notation, this is what we call Avogadro's number. And we use moles in everything because a particle is very, very tiny, and you can see how small these particles are and how many are in a mole. So here is some common substances here. This is what a mole represents in each of these. So you'll notice that a mole of copper looks very different than a mole of copper 2 sulfate pentahydrate, looks very different than a mole of sucrose. Now, here's the problem with moles. We don't have a piece of equipment we can use to measure moles. So, whereas we go into the lab and I measure temperature with a thermometer, or I measure pressure with a barometer, and I measure mass with a electronic balance, there is no piece of equipment to measure moles. Therefore, what we do is we measure the mass, and we have to be able to convert between mass and moles. And that connecting point we use to convert there is called molar mass. So what I want to work with you today is I would like us to figure out the molar mass of some common substances. So the substance we're going to start with is really easy. We're going to start with the substance H2O, and we're going to figure out the molar mass. So to do this, you need your data booklet. And again, you're going to open up to the periodic table, and the number underneath the name of each element, that is the mass number. And so in water, water has 2 hydrogens, and water has 1 oxygen. So if we look up the value, we have 2 hydrogens, and each hydrogen has a value of 1.01. And so that's going to be 2.02. So make sure you're looking up these numbers with me or pausing the video. Oxygen, we have 1 of them, and the mass number for oxygen is 16.00. So 1 times 16 is still 16. And then what we're going to do is we're going to add these two numbers up. So 2.02 plus 16 is going to be 18.02 grams per mole. And that is the unit for molar mass. That's the number we're always going to use. So I'm going to clear this screen. We are going to go to the next screen. I would like you to pause the video as you figure out these 3 molar masses. When you are finished, unpause the video, check your work with mine. Here I go. So I have 1 sodium, 1 oxygen, and 1 hydrogen in sodium hydroxide. So this is 1 times 22.99 is going to be 22.99. 1 times 16 is going to be 16. And 1 times 1.01 is going to be 1.01. So we started with an easy one. When I add these 3 numbers up, it's going to add to 40 grams per mole. Let's do the second one. We have 1 copper. We have 2 hydroxides, so that's 2 oxygens and 2 hydrogens. So 1 times the value for copper is 63.55. We have 2 oxygens at 16 each. So that's 32. And we have 2 hydrogens at 1.01 each for 2.02. When we add all this together, it's going to add up to 97.57 grams per mole. And the last one, we have 1 potassium, we have 1 manganese, and we have 4 oxygens. So 1 times 39.10 is 39.10. 1 times 54.94 is 54.94. And 4 times 16 is 64. When I add these three together, I have 158.04 grams per mole. Hopefully you got those right or you've made your corrections. I'm going to clear my screen. Now, what I want to do is I want to teach us our new formula. This formula is on page 10 in your data booklet, and my suggestion is take a highlighter and highlight the formula, as well as highlight that M to the right of it in your data booklet stands for mass. Mass is measured in grams. Capital M, what we just solved for, is called molar mass, and you've already seen it's measured in grams per mole. And also N is moles, and that's my chemical amount, and it's measured in moles. What I would like to do is also show you quickly how we can move this formula around to solve for mass if we wanted to. The rule in a multiplying dividing formula is if you want to solve for a variable, anything that's in here that you're moving, when it crosses the equal sign, it's going to change floors. So since the capital M, the molar mass, is in the denominator, when it crosses the equal sign, it's going to go upstairs. It's going to change floors. And your formula is going to be mass equals moles times that molar mass value. So let's clear this off. You could write that formula down too if you wanted. And we are going to go to the next page. What I would like to do is go through how we do one of these formulas. So we want to calculate the chemical amount, which means we are trying to find moles. That's what chemical amount is. They gave us a mass in the question of 5.50 grams. And we know the substance is magnesium chloride, so we can find molar mass. Molar mass is going to be 1 magnesium plus 2 chlorines. So 1 magnesium is 1 times 24.31, which is 24.31. 2 chlorines is 35.45 each, which is going to be 70.90. And we're going to add these two numbers together. And my molar mass is going to be 95.21 grams per mole. Now, in my room, you'll get a mark for calculating molar mass, but you also get 3 marks for doing the question. And the first mark is you opened your data booklet and you copied the formula that we're going to use. That is worth 1 mark. The second mark is for substituting in the numbers. So in place of little m for mass, you are going to write in 5.50 grams, and I need the units attached. No units, and I'm not going to give you the mark. The molar mass we just calculated was 95.21 grams per mole. So first mark, formula. Second mark, substitution with unit. Third mark, we're going to get the answer. So I'm going to take 5.50 divided by 95.21 grams per mole, and the answer comes out to be 0.0577767 yada 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 moles. Well, the question has 3 significant digits, so I'm going to put my answer in 3 significant digits. So it looks like this one rounds. So this guy's going to round up 0.0578 moles. So you get a mark for answer with a unit attached. 3 marks. Again, I'm going to give you a mark for calculating molar mass in this formula. So this question's actually going to be at a 4. What I would do if it was me is I would pause the video, do question number 2 for yourself, stop, start the video again, check your answer with me, and then we'll move on to question number 3. So in the question, the mass had a value of 16.8 grams. We are trying to find what amount in moles. So we again are trying to find N. And my molar mass this time is for iron. Very easy. So we're just going to have 1 Fe, which when we look it up is 55.85. grams per mole. This question actually significantly easier than the last. So you get a mark for the formula. Moles equals mass over molar mass straight out of your data booklet. You're going to substitute in 16.8 grams on top. We're going to divide by the molar mass you just looked up, 55.85 grams per mole on the bottom. And now we're going to type it into our calculator. 16.8 divided by 55.85. And my answer in 3 sig digs is going to be 0.301 moles. Again, formula, substitution, answer, 3 marks, molar mass for the 4th mark. We're going to erase this. Now what I would like us to do is let's solve for something different in this question. So this time I want to know what is the mass. I'm going to solve for M. They tell me in the question, I now know I have 7.50 moles of water. So we got to calculate molar mass. Now we've already done this one today. So it's 2 hydrogens at 2 times 1.01. So that's going to be 2.02. We also have an oxygen at 1 times 16, which is going to be 16. So this adds up to 18.02 grams per mole. And that exactly matches up with what we did earlier. So we get a mark for the formula out of the data booklet. You are copying it exactly. If I am solving for mass, I'm going to have to move this up. So mass equals moles times molar mass. You get a mark for the new formula. We're going to take 7.50 moles. We are going to multiply it by 18.02 grams per mole. And my answer is going to be 135 grams. 1 mark formulas, 2 mark substitution with units, 3 marks answer, and you found sig digs. So that's 4 marks. What I would like you to do is copy down question number 4 and pause the video. And I would like you to try it for yourself, pretty please. So while you're doing that, I'm going to work ahead. We are trying to find mass. We know the moles in the question is 0.250 moles. Molar mass, we have 1 K, we have 1 Cl, we have 3 O's. So 1 times 39.10 is 39.10. 1 times 35.45 is 35.45. And 3 times 16 is going to be 48. When we add these 3 numbers together, it's going to work out to be 122.55 grams per mole. And so we're going to, again, formula out of the data booklet. We're going to solve for mass. So we're going to move the formula around. Mass equals moles times molar mass. Take 0.250 moles, times it by 122.55 grams per mole. And the answer is going to work out to be 30.6 grams. I hope you found this video very informative. Please check over your work, and if you have to, watch the video again.